Jeremy S. Cook here, and I've got a set of bits made by Wiha that are pretty good. Got a driver and an extension, so if you need to reach into some place you can't normally access, it's pretty easy. This makes it nice and long, and you can put it in, whatever, drive down the bits you need to. But what if you need something a little bit shorter, something to get into places that normally you couldn't? I didn't have a real good solution for that, so I actually 3D printed something. The biggest thing was making the internal hex on this, measuring it out. It's about 0.156 inches, and I modeled that out on Fusion 360. This is just a regular circle, extruded that, and then put the hex pattern in the middle. This is pretty easy to do. It's got an actual function for that, so you don't have to calculate all the angles and draw it out by hand. It's just really easy. You do that, extrude it. Now, there's the results there. The problem was I didn't put nearly enough clearance for this. Apparently, once the PLA is extruded, it kind of expands a little bit, so it's not quite the same as machining it, I suppose. So on the second version, I decided I'd just go all the way on this, actually put a magnetic holder on this, and I went through several revisions of this. I also put on a knurling surface on the outside. Now, this started out with something called a coil on the outside. Other drafting systems might call it a helical sweep, but you do that halfway around on the full length of your cylinder. And then from there, once that's done, you can mirror it on the surface. From there, you just do a circular pattern, and from there, that's all there is to knurling something. It was actually quite easy once I figured it out. From there, you can play with how many knurling surfaces and stuff are on there, and just get something that really looks good to you, because that's kind of what it's about, how it looks and feels. From there, I put a fillet on the inside of the hex, and eventually I put one on the outside too, but you'll see that in a minute. So this is the third version of this, believe it or not, and that went in pretty nicely, and the magnet went in too. Looks pretty good, but the thing is that magnet, it just flips right out. Ideally, I wanted that to be a press fit, so I went back to Fusion, redesigned a few things, and then printed a new version out. Now this new version actually did work as a press fit somewhat, but it wasn't very good, so I had to hot glue it down on the outside. This would have worked, but as you can see, there's another 2 minutes left in the video, so I did make a new version eventually. What I did here was, first of all, I put a fillet on the outside of the outside, because I thought that would look pretty good. And then the big thing about this revision is I actually put a channel down the inside. Left the rest of it the same diameter, but this channel would allow me to press fit 2 magnets in the middle and then have it lock in pretty easily, pretty well. And with this design done, I printed it out, and then after that I press fit the magnets in the middle. Used my milling machine for that. This spindle locked it down. This is really good use for this, besides actually cutting things. Obviously you could use a hammer or whatever else. After that it was nicely magnetized and slid the hex bit right in. Or it could have used a Phillips or flathead bit too. And there's a little demonstration of it taking the hex bolt out of this. That's actually some Activotics, a slider that I use in some of my videos. And goes back in. Now if you put a lot of torque on it, it does seem to kind of deform the inside a little bit. So I think this would wear out eventually, but for intermittent use, it's pretty good. You can see it there in a more restricted space. It does work, although it is a little bit tight for it. So I hope you liked the video. If you did, make sure you give it a thumbs up, subscribe, or even leave a comment. Oh, and one more thing. If it's too tight, it is hard to get it in there correctly. So anyway, this is Jeremy S. Cook signing off. Thank you for watching. Bye.